So today we are going to see the concepts of pointers in C. Pointers, basically it has been misunderstood as one of the toughest concept in C programming language, but if you understand it is very interesting. Pointers are basically not available in the latest programming languages like Java or .NET technologies. So anyway, let's get into the fundamental concepts of pointers in this particular session. So before we move to the concept of pointers, first let us try to understand what is the role of a primary memory in a computer system. So let's say, for example, if we are supposed to do some manual calculation without a paper or without any calculator devices, what we do is we used to store the particular value or a particular data in our human brain as a memory. So we just memorize the thing and then we try to do some kind of manipulation, and then we work it out in our mind with the help of the brain to compute something, and then we point out the results. But what happens when in terms of a computer system, we write so many programs, we write a lot of lines of code, we have so many number of variables that has been used inside our code. Now how these are getting worked out or how these are getting executed? Because from a programmer perspective, we just write the logic after knowing the syntax or after knowing how to write a particular piece of code, but how it works out. So normally speaking, we need a particular memory for a computer system in order to execute your program as well as the information that has been used inside a program. So primary memory is one thing that is available in your computer system that can handle different data and programs that are placed for execution. So normally when you write a program, you have certain information that has to be processed, and that processing can be executed inside a primary memory. And always remember, your primary memory is actually a collection of memory locations. So we treat it as a RAM or random access memory, which consists of a lot of memory locations. So what happens here is every location is going to have an address. That is, in order to identify where that particular information is getting stored, every location will have an address. And there are three areas of main memory, that is the stack, heap, and then the global memory. So in the next few minutes, we are going to see what is going to be a stack, what is the difference between stack and heap, and how the global memory is going to work. So to starting off with the stack is actually a fixed size memory. So normally speaking, when we have so when I say about a fixed size memory, so let's say for example we try to view stack as a jar. So let's say for example you have a jar in your kitchen and you are trying to put some grocery item inside that particular jar. So what happens is the jar starts filling from the bottom and then it reaches the top. So similarly, stack is actually a fixed size memory. So let's say for example here I have a stack whose size is 2. So which means this particular stack can accommodate 2 elements or 2 data. So let's say for example I want to fill the item 10 inside this particular stack. So filling up of elements inside a stack starts from the bottom and it reaches till the top. So let's say for example I am trying to insert the value that is 10 inside my stack. So what happens is 10 is placed at the bottom and the remaining elements will pile up on top of the 10. So next I'm trying to insert an element that is 20. So now my stack is full. So the size of my stack is 2 and I have filled out 2 elements inside my stack. So basically when we try to insert some value or item inside a stack, we start from the bottom and then we reach at the top. So how to access the elements inside a stack? So always remember, whenever you are trying to identify an element inside a stack, or if you want to remove an item from a stack, the first and foremost element that has been touched in a stack is the topmost element. So if I want to remove the element 20, so 20 has to be pushed out of, 20 has to be popped out of the stack, and so now I have the element that is 10 that is remaining inside my stack. And if I want, so 10 is going to be the top element inside my stack as of now. And if I want to remove an item, so again 10 will be the top element in my stack and 10 will also be removed. So now my stack remains empty. So always remember, your stack is going to be a fixed size memory and you start filling up the item from the bottom, and once you start filling up from the bottom it reaches the top, and whenever you want to remove an item from the stack, the topmost element from the stack will be removed. So this is the basic concept about stack. So it will be filled up from the bottom, so you start filling up the elements or data or the information from the bottom till the top, and if you want to remove an item from the stack, then the topmost element in the stack will be removed. So this is something similar to how you submit your notebooks in your school or in your college to a particular teacher, what happens is the first student is going to place the note on the table, and the second student will place it on top, the third student on top of the second student. So like that it goes on, and when the teacher starts to correct the particular note, he or she will take the topmost note that is available in that particular pile. So that is something, a live example to understand the concept of stack. So whenever you are trying to remove a particular item from a stack, the topmost element from the stack will be removed. So the last element to the stack, whatever is available, will be removed first. Okay, so you can do this operation only one at a time. So in a stack, whether inserting an element or removing an element can happen only once at a time. So technically speaking, inserting an element is called as a push, and deleting an element is called as a pop. So next we will see about the concept of heap. So heap is also a fixed size memory, but it's actually a contiguous block of memory. So continuous block of memory. So something similar to your stack. So what happens is whenever, so this is just a small illustration of how your heap looks like. Okay, so this is actually your heap that consists of different memory blocks. So block 1, block 2, block 3, block 4, like that. So there are 4 blocks. There are 4 blocks that are available. So let us identify these blocks are free, and I'm maintaining a separate free list whenever these blocks are free. So heap is actually a contiguous block of memory. So whenever a program requires a memory to execute its code, what happens is whenever there's going to be a requirement from a particular program to use a memory, okay, so whichever block of memory is free, that particular memory can be allocated to the particular program to be executed. So your fixed size heap is allocated, and it is being used randomly by the system. So the code block, the memory block, whichever memory block is free, that memory block is being allocated by the system randomly to your particular program. So this is generally a principle of the dynamic allocation. So where you can take a particular block which is free in the heap, and then it is assigned to a program. So let's say, for example, there are 4 blocks that are free, memory blocks that are free. So out of these 4 blocks inside the heap, I can take any block, and that can be assigned to the program for execution. So this is called as a dynamic allocation. So there is no rule or there is no principle to choose which particular block has to be allocated to the program. So the program, once it is getting executed, or once it consumes the memory block, and it is free after execution, that particular memory block will be returned to the heap. So this is the concept of heap, something similar to your stack, but there is a slight difference between heap and stack. So basically speaking, stack is pretty small, and it is faster too when compared to the heap, and since it is very small and fast, stack is expensive when compared to the heap. So all the variables in the function that we are using are allocated on a particular stack. So basically your function operation as well as your variable allocation inside a function, it has been executed on top of a stack. So parameters, whatever is being passed to a called function, will be stored inside a stack. So there's something about the difference between stack and heap. So next we will try to move on to the global memory. So when we speak about the global memory, the actual block of code that is getting executed will be stored inside the global memory. So for example, your main function that has been the heart of your program will be stored inside the global memory. So whatever may be the global declarations that you have done before the main, all will be stored inside the global memory. So this particular global memory will be allocated randomly. So as I told you, whatever functions that are there inside your code block, so let's say for example there is a particular main function, and this function is going to, or your program is going to have let's say for example n number of functions. So all these n number of functions will not be placed contiguously. So what happens is they will be placed somewhere randomly in some memory location, and in order to store the global variables, we are going to make use of the global memory. So the variables or the function declaration that happens outside your main function or before the main function definition, they all will be stored inside the global memory. So this is some of the areas of the primary memory that we have seen. So stack, heap, and then the global memory. These are the 3 areas of your primary memory. And moving forward, we are going to see about the introductory concept of pointers. here, before we see about the concept of pointers, first let us try to understand what is the role of a variable when it is getting declared. So basically, whenever I say about a variable declaration, it means that some kind of memory is being allocated in order to hold or in order to have a particular value for that particular variable. So we might be aware about how we declare the variable. So basically, we need a data type and then we need a name of the variable, and that should be assigned to some particular value. That variable should be assigned to some particular value. So always remember, whenever we have a variable that has been declared, so let's say here for example marks is my variable, the data type of the variable is integer, and as of now this particular variable is holding the value that is 100. So when this particular statement is getting executed, it just means that some memory is being allocated in order to hold the value 100. So since marks is a variable of integer data type, integer will hold 2 bytes of memory. So what happens is, in order to store the value 100, the particular memory allocation is required is 2 bytes. So every variable will have a value as well as a memory location. So let's say let's see a very practical example. So here what happens is 2 bytes of memory location are being allocated for the variable marks, and it is holding the value that is 100. So basically marks is my variable, so marks has got a memory location. Since mark is of integer data type, so 2 bytes of memory are being allocated to the variable the marks. Okay, so 2 bytes of memory allocation, so 1003 and 1004 is the memory location. So 1003 is 1 byte and 1004 is 1 byte, so both put together it is of 2 bytes. So 2 bytes of memory is being allocated for the variable marks, which is of a integer data type. So what is the value that the marks variable is holding on? The value that it holds on is 100. So I repeat again, so variable is going to have a value and then it is going to have some memory location. So what about the pointers then? Pointers basically what it does is, it is going to hold the address of another variable. So very easily to say, your variable that contains the address of another variable is called as a pointer variable. So basically your pointer variable is going to represent the location of a data. It is not going to tell the exact data, but instead it is going to tell you the memory location of a particular data. So here let us first discuss about the applications of pointers, then we will see how you can declare a pointer variable and its usage through a code. So what happens is, you can pass the values between function and then its reference point using the pointer variable. So normally speaking, when we use a function, we try to pass different values to the function definition and then we try to work it out. So in order to pass the values between the function and its address point, we can make use of the pointers. This again, we will discuss this particular concept with respect to calling a function by value as well as calling a function by reference. And your pointer can also return many data from a function through function arguments. So theoretically, we have an impression that every function can return one value, but there is a separate a function, that is, we call it as a function pointer, which can return many data from a function through the pointer arguments. So this again we will discuss later, but as of now you just know the applications. So there are pointers can provide you the other way of touching the elements that are present inside your array. So it provides the alternate ways to access your array elements. And also pointers can pass arrays as well as strings as the function arguments, and you can create non-linear data structures like trees, linked list and graphs through the pointers. And at the last you can see that pointer is one way through which you can dynamically allocate the memory for a variable. So these are some of the applications that that is the outcome of the pointer concept in C. So next we'll see how you can declare a pointer variable. So basically speaking, your pointer is going to provide the feasibility to a variable by using the address of the variable. So let's say for example, you have a variable that can store the address of another variable. So that is basically the definition of a pointer. So a pointer variable will store the address of another variable. So if you see the syntax of pointer, basically speaking, it is something similar to how you declare a data type for a variable. So usually in the variable declaration, what we do is we declare the data type followed by the name of the variable. But for pointer, again we are going to give the data type followed by a unary operator, that is asterisk, and then followed by the pointer name. So this pointer name is going to be something similar to your variable name. Your pointer is going to point to some integer variable. So the address of the integer, so it is going to point out the integer variable. So the data type of that particular integer variable will be identified as the data type of your pointer variable. So here, let's say for example, I have declared a pointer, that is star is the unary operator that I use. So the unary operator star, that is asterisk value. So asterisk is used in order to indicate a particular variable is a pointer variable. So asterisk followed by the name of the variable is being identified as a pointer variable. So this particular pointer variable is of integer data type, which means this pointer number is going to store the address of another variable, and that variable is of data type integer. I repeat again, this pointer variable number is going to store the address of another variable, and that variable is going to have the data type as integer. So basically the data type of the value that the pointer will be pointing to has to be mentioned during the declaration of pointer. So let's say for another example, here I have declared a character pointer. So the name of the pointer is ch, and it has been given with the prefix of asterisk symbol. Okay, so the asterisk symbol indicates that ch is a pointer variable, and it is of a character data type, which means ch is going to hold the address of another variable, and that variable and that variable is of a character data type. And let's say for example, here I have another pointer declaration of float data type. So pi is a pointer variable. So here if you see, pi is a pointer variable that will hold the address of another variable, and that variable will have a data type of float. So we will discuss more with some examples which will be convenient for you to understand. So I'm straight away going for an example. So what happens is, here I have declared a simple variable that is marks of integer data type, and that marks is holding a value of 100. Next, what happens is, so once this particular statement is getting executed in my memory block, so this is my memory block. So it starts with the memory location of 1001 and it ends with 1008, let's say for example. So since marks is an integer data type variable, so 2 bytes of memory allocation will be allotted for the variable marks, and it is holding a value of 100. So 100 will be located in 2 bytes of memory location, that is 1003 and 1004. Now in the next statement, I am trying to declare a pointer variable, that is the name of my pointer variable is point. So the data type of the pointer variable is integer, which means point is a pointer variable that will hold the address of another variable which is of integer data type. I think the next statement will be pretty clear for you. So what happens is, this is an assignment statement. So you just first process the right hand side. In the right hand side you have the variable that is marks, which has been given with the prefix of ampersand symbol. So the ampersand symbol indicates the address of the variable that is marks. The ampersand symbol indicates the address of the variable that is marks. So the address of the variable marks is being stored to the variable that is point, which is actually a pointer variable. Okay, so here first let us try to understand. So I told you point is a pointer variable that will hold the address of another variable. So here we have just simply declared, in the second statement we have just simply declared what is my pointer variable. I have simply declared what is my pointer variable, but this pointer variable should hold the address of another variable na. So next statement I have to indicate what will be the address holded by this particular pointer variable. What will be the address that the particular pointer variable will be holding. So here what I am doing is, I am taking the address of the variable marks, and it has been assigned to the pointer variable. So this is a very important point. So first thing is, we are going to declare the pointer using the unary operator, that is asterisk. In the next statement you have to take the pointer name. The pointer name should be taken, and that should be assigned to the address of another variable. So as I told you, so point is the name of the pointer. So point is going to be the name of the pointer, and integer. So as I told you, this particular pointer variable is of integer data type. So it is going to store the address of another integer variable. So mark is the integer variable, and its address will be stored in the pointer. Okay, so integer variable is going to point to another integer variable. Now, so as I told you, marks is the variable name, and that has been declared as an integer data type. So I am going to allocate 2 bytes of memory location for the variable marks. So this is my memory representation. So starting off with 1001 to 1008. So 2 bytes of memory locations are being allocated for the variable marks, which is of integer data type. So 2 bytes of memory location, that is 1003 and 1004 are the memory locations where I am going to store the value 100 through the variable that is marks. So what happens is, what will be the address of the variable marks then? So here I have the memory byte location that is 1003 and 1004, but actually the address of the variable marks will be 1003. So even though I have 2 bytes of memory allocation, the first one will be taken into consideration for the address of a variable. So let's say for example you have a float variable. Float variable will hold 4 bytes of memory location. So let's say for example it takes the value 1001, 1002, 1003 and 1004. So if you see the address of the variable for a float variable, it will take the first byte of memory location. So similarly in this particular case, marks, it has been allotted 2 bytes of memory location 1003 and 1004, and still the first byte memory location will be allocated as the address of the variable marks. So now, as I told you, we had the third statement, that is the pointer variable will store the address of another pointer. It will store the address of another variable, like that we told. So what happens is, the address of the variable marks will be assigned to the pointer name. So what is the address of the variable marks? The address of the variable marks is 1003, and this 1003 will be holded by the pointer name point. So now the point will have the address that is 1003. So 1003 is the address of marks. So point is a pointer variable that is going to hold the address of another variable. So always remember, your pointer variable is not allowed to store the actual memory address. So you cannot directly allocate a memory address to a pointer variable like this. This is actually wrong. So basically your pointer variable should be declared, and this pointer variable should be allocated to or assigned to the address of another variable. So direct allocation of the address to a pointer variable is not allowed. This is wrong. So the next thing is how you can retrieve the value of a particular variable that is present inside a memory location. So far what we have seen is, whenever we have been given with a particular pointer variable, we are assigning the address of that particular variable through the pointer variable. So through the pointer variable, we are able to access the location of another variable. Now how can we retrieve the value that is present in that particular location through the pointer variable? So let's say for example 1003 is the address of the variable that is marks. Now in this particular memory location we have the value 100. Now how can we access the value of 100 through the pointer variable? Because the pointer variable is holding the address of another integer variable. So now we have to understand how we can retrieve the value that is present in the corresponding memory location through the pointer variable. So this particular concept is called as dereference, so that you can retrieve the value of the variable to which the particular pointer variable is pointing. So as I told you here, the pointer variable holds the address of the variable that is marks, and in order to retrieve the value that is present in that memory location 1003, we are going to make use of the concept of dereference. We are going to make use of the concept of dereference in order to retrieve the value of the variable to which the particular pointer variable points. So here we have to make use of the unary operator star again. Okay, this star operation, the star operator is called as an indirection operator in order to retrieve the value of the variable to which the particular pointer variable is pointing to. So for example, I have declared the variable that is marks, the value is 100, it is stored in the memory location 1002. It is holding 2 bytes of memory location, and immediately I am declaring a pointer variable. and in the next statement I am assigning the address of the variable marks to my pointer variable. So now the variable point, the pointer variable point is going to have the address of the variable marks. So pointer is going to have the address, but how can we retrieve the value that is present in the corresponding address? So point will hold the value that is 1002, but how can I access this particular value with the help of the address? So here we have to make use of the indirection operator or the unary operator star. So what I'm going to do is, before this particular pointer name, I'm going to add the star value. I'm going to add the star value. So the star followed by the pointer name, it indicates, so already the pointer name has been assigned to the address of your marks variable. So what happens is, you are going to make use of the unary operator asterisk symbol. You are going to make use of the unary operator asterisk symbol that is applied in the address of the variable, that is marks. So what will happen is, your address of the variable marks has been carried by the pointer variable point. So before that, what I'm going to do is, I'm going to make use of the dereference operator, that is a star operator. That's a star operator. Okay, so your star operator followed by the pointer name will actually retrieve the value of the variable. It will actually retrieve the value of the variable. So your star symbol followed by the pointer name will actually retrieve the value of the variable in the corresponding address. So now the star point value will have the value that is 100. So if you have any queries, you can post your queries in the comment section. Okay, thank you.